In this video, we'll be verifying trig identities. So we'll be looking at what it means to verify a trig identity, and we'll also talk about some hints, and then we will actually do one identity. So we practice verifying trig identities to develop the skill of writing expressions in alternate forms. To verify an identity, we take steps to rewrite one side of the equation so that it's eventually identical to the other side. Note, verifying identities is not the same as solving an equation. When we're verifying a trig identity, you only work with one side of the equation. You don't do the same thing to both sides. So we only work with one side of the equation. Some hints for verifying identities. And these are just things to try if you... First of all, it's important that you learn the fundamental identities. It helps to rewrite the more complicated side. And then also sometimes it helps to rewrite in terms of sine and cosine. If possible, you may want to factor. And then always keep the other side of the identity in mind as a goal that you want to reach, because you're working on one side to eventually get it to look like the other side. And then also multiplying the numerator and denominator of a fraction is helpful. Our example, we're asked to verify the following equation is an identity. So we already know this is an identity, and we're just going to verify that it is. So we know that this left side is equal to 1, this right side. We just need to work on this left side and rewrite it using our fundamental identities so that eventually it equals 1. Now let's draw a line down where the equal marks is so that I can just work on this left side. Some things that I might want to try is to rewrite each of these trig factors in terms of sine and cosine. We have a cotangent x multiplied by a sine x multiplied by a secant x. So I may change this cotangent x using my quotient identity to cosine x over sine x, and then that's multiplied by sine x. Well, I'm going to leave that alone. I'm just going to write it over 1 so that I can see if some things are going to cancel. And then we know from our reciprocal identities that secant x is the same as 1 over cosine x. Now we know that a factor in the numerator can cancel with a factor in the denominator if they're the same. So this cosine x over this cosine x is equal to 1, and so we can cancel those out. And then also this sine x over this sine x, that's equal to 1 as well. So we have 1's and 1's. When I do the multiplication here, I get 1, and then we can say that that's equal to 1. So by just showing this change, and doing the multiplication, I've proven that this product is equal to 1.